Hello, assalamu alaikum, welcome everybody, and today I'm going to be reviewing quiz 2. So this is lesson 2, the periodic table. It is pages 16 to 27 in your book, this guy here. Um, yep, and so let's just dive right into it. What we're going to be doing is I'm going to be posting a link in the description with the worksheet that I'm working through. This worksheet is kind of a revision worksheet for the quiz. So what I suggest you do is maybe print it out, or if you don't have a printer, you can have it on your iPad and try and work through it as I work through it. Okay, so try and actually do the questions, pause the video, try and do the questions yourself, think about it before you play the video, and obviously reveal the answer. Okay, so let's go. Alright, so here are some questions, and of course it's about the periodic table, and let's get into it. So we've got some multiple choice questions. Elements in the same group of the periodic table have similar what? So if they're in the same group, this is what we mean. This is a group. These are groups. So groups or families. This is a challenge to write sideways. So these are called groups or families. So the columns are groups or families. Okay, so if they're in the same group, they're in the same column, they're in the same family. Okay, so how many groups do we have? We have 18 groups. Over here, I've got the first 8. So 1, 2, 3, 4, 5, 6, 7, 8. But technically, it's not 8, it's 18. So sometimes you'll see a teacher say, for example, noble gases are in group 8. But technically, they're in group 18. So why do we say 8 then? Well, because we kind of just don't always mention the transition metals. We kind of get sick of mentioning them all the time because we're mostly concerned with the first 20 elements. So that's why sometimes you'll hear teachers say 8 groups instead of 18 groups, and it's kind of correct. So anyway, elements in the same group of the periodic table have the same properties. Okay, they have the same properties. They don't necessarily have the same colors. They don't necessarily have the same mass. Of course they don't have the same mass, because obviously the elements are arranged by atomic number, and so they have different proton numbers, and they have different neutron numbers, and they have different masses. So definitely not mass, definitely not color. What about atomic numbers? Of course not. The whole periodic table is arranged through atomic numbers. So they've got hydrogen, atomic number 1, helium, atomic number 2, which means 2 protons, and then lithium has 3, beryllium has 4, and so on and so forth. So the answer is properties. The alkali metals include what? So alkali metals are these guys here in group 1, all the way down. These guys here, okay? So that's group 1. And they include lithium, sodium, potassium, rubidium, cesium, and francium. So which ones are these? Well, sodium and potassium. That's pretty easy, okay? Sodium and potassium. What about copper and zinc? These are here in the transition metals. Look, that's copper right here, and that's zinc right here. So they're in transition metals. What about iron and silver? Once again, transition metals. That's iron, and silver is all the way down here. So those are transition metals. What about calcium and magnesium? Oh, calcium, magnesium. These are in group 2, alkaline earth metals. So they're not alkali metals. Okay, just be careful with that one. The 2 most common alkaline earth metals are, well, now this question might come across as a bit confusing, because you might be saying, well, I don't know which ones are most common and which ones are not. So the way to answer these questions is look at the options, see what the options tell you. I mean, the first option says copper and zinc. These aren't even alkaline earth metals. They are transition metals. Same as those ones. These are alkali metals, so there's not even alkaline earth metals. So the only option left is calcium and magnesium. And guess what? They are alkaline earth metals, and they are the most common. So the answer is D for that one. Let's keep going. Which statement about elements in the same group or column is correct? They have the same atomic number? Absolutely not. Remember, the whole periodic table is arranged by atomic number. So it's arranged by number of protons. That is the identity of the element. You can't have 2 elements with the same atomic number. they become the same element essentially. All right, so definitely not the first one. What about they have the same atomic mass? Well, that's also incorrect. Because remember, atomic mass is the number of protons and neutrons that an element has. So if they have the same atomic mass, that almost means like they're the same element. So no. What about similar characteristics? Absolutely. Remember what we said about alkali metals? We said that they're all highly reactive and they're all in the same group. They're all in the same family. They're all in the same column. What about alkaline earth metals? Well, guess what? They have similar properties as well. What about the oxygen group? Similar properties. What about the halogens? Similar properties. What about noble gases? All of them unreactive. Similar properties. So elements in the same group, elements in the same column, elements in the same family have similar properties. They all share similar properties. And properties are characteristics. Properties are things like reactivity, how they react, if they are explosive or not, or if they oxidize or not. So these are different things that the elements do. So different reactions, all right? So they all have different similar characteristics or similar properties, means they kind of act the same way, okay? Completely different characteristics? I mean, think about it. You and your siblings are kind of very similar. And you might think you're different, but you're similar because you're all in the same family, right? And I'm sure you've met people before and you've thought, you know what? Do you know Yusuf? And they're like, yeah, Yusuf is my brother. I was like, oh my God, I knew it. You guys act the same way. Guess what? People in the same family kind of act the same way. And that's the same thing as elements. So elements in the same family act the same way. The modern periodic table is organized according to what? Oh, we have to go through this, right? So Mendeleev, this Russian scientist who first came up with this idea about organizing the periodic table, he wanted to organize the periodic table by the element's mass number, right? And that's how he did it, through the mass number of the elements. Now, modern periodic tables are organized by atomic number, by the number of protons elements have. So the modern periodic table is not organized by the mass number or the neutron number or even the element's color. They are organized by number of protons. Okay? Now you might be thinking, but all of these are blue and all of these are red and all of these are green. These are not the element's colors. This is just the colors we use in the periodic table to differentiate between metals, metalloids, and non-metals. Okay? So metals are obviously things that like conduct electricity and they have like the silver shine and they're a bit sonorous when you drop them, and you know some of them are magnetic, and yeah, so those are metals. And then non-metals are brittle and they're not malleable, they're not ductile, they don't conduct electricity, they don't have high melting points like metals do. And then metalloids are things in the middle. So those guys here, metalloids, they're the ones in the middle that kind of have properties from both sides. They have characters from both sides, both metals and non-metals. And they're very useful in electronic components and circuit boards. But we'll come to cover these later. So for now though, let's go back. For now though, all you need to know is that elements in the same family have similar characteristics, and the periodic table is organized by number of protons or atomic number. Okay, question 6 now. Let me change the color though. Blue is nicer, I think. In the periodic table, the most reactive nonmetals are found in what? Remember, the most reactive metals are these guys here, the alkali metals. These are the most reactive metals by far. Very, very reactive. In fact, they're so reactive, they're angry. I'm going to draw them like that. But they are metals at the end of the day. Now, what about the most reactive nonmetals? Well, nonmetals are in green, okay? See? Nonmetals green, metals blue. So I'm going to draw them like this. These guys here are the most reactive nonmetals. And I'm going to draw them like this. Okay? And nonmetals, I'm just going to go with a go. Metals are boys, nonmetals are girls. Don't ask me why, I just made it up. Okay. Right? So the most reactive nonmetals, well, that's group 17 or group 7. Group 17. Let's keep going. Back to, I think I'm just going to go with red now. Back to red. In the periodic table, the most reactive nonmetals are found in. Oh, we just answered that. Group 17. Iron, copper, and nickel belong to the family of elements called what? Let's see. They are over here. What is this family called? This family is called transition metals. They are the transition metals. Okay? And where's this iron, copper, and nickel you speak of? Well, there's nickel, there's copper. Oh no, that's cobalt. There's nickel, there's copper, and there's iron. They are all transition metals. Okay? So they belong to the transition metal group. Okay? Definitely not the noble gases, which are over here. Oops. This is where the noble gases are. And definitely not in the halogen group or the alkali metal group. That's silly. They're in the transition metal group. Okay, from an element, which element has the atomic number 50? Well, that's easy. Oh no, we're here. We're number 8. Sorry, number 8. Fluorine, chlorine, bromine are part of which family? Well, fluorine, chlorine, bromine, iodine, astatine. They're all part of the halogen family. They're right here, group 17. They're the most reactive nonmetals. Most reactive nonmetals. So they are, most reactive nonmetals. Yes, they are the most reactive nonmetals. They are the halogen group. Over here is where they are. Which element has the atomic number 50? Now we can do that question. Here it is, number 50. Number 50. What is that? Well, that, my friends, is tin. And you might be wondering, well, why isn't tin Ti? Okay, well, first of all, we do have Ti. It's called titanium. But also because some of these names come from Latin. They don't come from English. And so, the names in Latin are different to English. Right. From an element's location in the periodic table, you can predict what? What can you predict about the element from its location in the periodic table? Well, there's a lot. You can predict whether it's a metal or a nonmetal. You can predict its reactivity. You can predict whether it's oxidizing or non-oxidizing. You can predict whether it's unreactive, like, the noble gases. You can predict how heavy it is. But let's see. The most accurate answer here is obviously the properties. That's it. The properties, the characteristics, how it reacts. Okay? Let's keep going. Oh, we're nearly there. Good. We're doing well. Write the correct family next to each description. Noble gases, halogens, alkali metals, transition metals, and alkaline earth metals. Soft, very reactive metals that can be cut into with a plastic knife. So for my class, I've shown a video in the class about the reactivity of alkali metals, and it's amazing. Alkali metals are very soft. You can cut them with a knife, all right? And you drop them in water, and they immediately start reacting. They start fizzing, and then if you go down the group, like from lithium to potassium to sodium, they start catching on fire and sparking. And then if you go way down, like rubidium and cesium, that's when you get explosions as well, like big, massive explosions. They are no joke. They are very reactive. So soft, metallic, reactive, that is alkali metals for sure. Alkali metals. So what do I need to do here? Write the correct family. Okay, so that's C. Alkali metals. Whoop. Here we go. Excuse my handwriting. Maybe I should go back to blue. The most reactive nonmetals. Well, we already know that by now. Halogens. Halogens. Group 17. Easy. Include iron, copper, and nickel. Okay, let's change that to orange. Iron, copper, nickel. Where is it? Here we go. Chromium. All of it. It's the same. There are transition metals. Transition metals. So that's D, transition metals. And when you're answering these questions, not transitions, when you're answering these questions, whoopsie daisy, it's always a good idea to have a strategy. So actually, it's a good idea just to do that, like just strike them out. That way you don't get confused. So we've done the halogens, and we've done the alkali metals. There we go. So I'm going to go to green now. Unreactive nonmetals that are gases at room temperature. Oh, that's lovely. So they're unreactive. That's the first thing. Unreactive. They are nonmetals and they are gases at room temperature. Which one is it? Guys, dead giveaway. Noble gases. They don't need anybody. They are unreactive. They don't react with anything. Those guys are noble. They don't need anybody's electrons. They don't react with anything. And they are stable. And they are gaseous. So helium is a gas, neon is a gas, argon is a gas, krypton, xenon, radon, all of them. They're all gases. So this is noble gases. Noble gases. Very good. Noble gases. And we kind of know the answer to the last one, but we might as well do it. Harder, denser metals that melt at higher temperatures. Alkaline earth metals. These are these guys here. So they are a lot denser than alkali metals. So alkali metals are soft and they actually float on top of water. But alkaline earth metals are much denser. They are slightly less reactive. They are reactive as well, by the way. They're just less reactive. They are denser and they exist in bigger amounts. Alkaline earth metals. And of course that is group 2. Okay? Group 2, and that is group 18 or 8. Okay, let's move on. Right, back to blue. Write the correct chemical symbol for each of the elements: manganese, cobalt, gallium, and cesium. Very interesting. So here's something interesting about gallium. Gallium has such a low melting point. If you hold it in your hand, it starts melting. It's got like a melting point of 35 degrees Celsius. And since the body temperature is 36 or 37, it melts in your hand. It's pretty crazy. Mercury as well is like the only metal that exists as a liquid. Okay, so let's keep going. Manganese. How do I figure out the symbol for manganese? Well, I've got the periodic table. What do I do here? Look, it's number 25. So all I have to do is go to 25 in the periodic table. Where's 25? Well, right here. Well, guess what? It's right here. It's Mn. There it is. Mn. What about 27? That's cobalt. 27. There you go. Co. Co. Easy. Gallium. Gallium is Ga. Number 31. Gallium. Ga. And don't forget, it has to be in capitals, right? And cesium, well, that's that powerful alkali metals that explodes, right? So it's over here, 55. That's the atomic number of cesium. That's how many protons it has. And it's CS. CS. That used to be the name of a game, Counter-Strike. I don't know if you guys remember that. Counter-Strike. I used to play it back in the day. Anyway, CS. Cesium. Moving on. Oh, we're nearly there. I think this is the last part. In what order did Mendeleev arrange the elements? Well, we should know that by now. Mendeleev organized the elements by atomic mass. Increasing atomic mass, I should say. So that means just going up, starting with the lowest one and then going up and up and up and up. Increasing atomic mass. What do elements in the same column have in common? Come on, guys, this is easy. So first of all, column means family or group. Okay, and that's different to this. That's period. Okay, this thing's called a period. Okay, that's period 2. That's period 1. That's period 3. That's period 4. That's period 5. That's period 6. That's period 7. There are 7 periods in the periodic table. 7 periods. But how many columns do we have? How many families? How many groups? We have... This is hard. 18. 18 groups, 7 periods. Okay, moving on. So what do the elements in the same column have in common? Similar properties. Okay. Now, it is at this time that I will say that elements in the same group in the periodic table also have same number of valence electrons. Now, I know we haven't explained that yet, and I'll explain it in class soon. But valence electrons simply means the number of electrons on the outside. So even though elements in the same family have different number of protons and different number of electrons, they have the same number of valence electrons on the outside. So this is crazy, but I'll explain it really quickly now. Like lithium has 3 electrons, right? So it has 2 electrons on the inside and only 1 on the outside. That's why it's in group 1, because it has 1 electron on the outside. Well, what about sodium? Sodium is lithium's brother, okay? Lives in the same family, obviously, in the same household, but he's got 11 protons. So that means how many electrons he's got? That means he's got 11 electrons. Well, guess what? This is what sodium has. This is sodium. He's got 2 on the inside, he's got 8 on the outside, and then he's got 1 more layer. And how many does he have in that layer? Can you guess? Same as his brother. He's got 1. So, because they're all in the same group. So, they both have 1 valence electron. That's because they're in the same family. And they're both in group 1. See? This is the big brother. And that is the little brother. And, of course, little brothers have their tongue sticking out. Anyway, so they have similar properties and they have the same number of valence electrons. But if you just say similar properties for now, that's fine. What can you predict about an element from its position in the periodic table? A lot, once again. So you can say whether it's metal or it's non-metal. Okay, whether, whether it's metal or non-metal. What else can you say? What else can you say? Come on. I can't hear you. Okay. Whether it's metal or non-metal, you can also predict whether it's reactive or not reactive. I mean, if it's going to be in group 18, obviously it's not reactive. If it's going to be in group 1, very reactive. I can predict whether it's metal or non-metal, whether it's reactive or non-reactive, and there's a few other things too. I'm just going to stop there though. Oh, well, I can say properties. I mean, once again, I can predict properties. Mendeleev organized the periodic table by what? Well, that's the same answer. That's the same question as the first one. Atomic mass. Atomic mass. While today it is organized by... Come on, guys, I can't hear you. Not all at once. Atomic number. Atomic number. So today the periodic table is organized by the number of protons. That's it. All the best. Keeping it short. Good luck. Take care. If you have any questions, don't forget, you can ask me on Teams. Bye-bye. Have a good one.